We've been backing up our databases over the past few videos. Now let's see how we can make use of those backups. Welcome to this video on backing up SQL Server. My name is Kevin Fiesel. I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. The past several videos have covered different ways that we can back up databases. Backups by themselves are actually not that important. It's the ability to restore a backup that matters the most. And in this video, I'm going to show you how you can restore backups using a variety of different tools. We'll start with SQL Server Management Studio. After that, I'll show you how you can use T-SQL to perform a restoration. Finally, we'll do the same thing in DBATools and PowerShell. Now, I think we've spent enough time in the classroom over the prior few videos, so instead, let's jump straight to a demo. For this demo, we are going to jump around a little bit between SQL Server Management Studio and the Windows terminal. I will show you how to restore databases in a variety of circumstances, including using the Management Studio UI, using T-SQL, and using PowerShell and DBATools. We will start with a simple example using SQL Server Management Studio and restoring a backup in the simple recovery model. Let's go with our standby database, Chicago parking tickets. I will right-click on the database and then select Tasks, then Restore, then Database. Starting from the top, I have a source, where I can select either a database or a device. By default, we start with database and the database we selected, which in this case is Chicago parking tickets. This option reads certain metadata in SQL Server's MSDB database, and we see that it has populated the latest copy-only full backup of Chicago parking tickets, which I took on October 11th. I can select Timeline, and it will show me the date and time of this particular backup. Now, this isn't very exciting because Chicago parking tickets is in the simple recovery model, and all we have is a full backup, so I'll hit OK. Selecting the Files tab, we can see any database files, including MDF, NDF, and LDF files. In this case, I only have an MDF file for hosting row data and an LDF file for hosting the transaction log data. We can see that there is an original file name and a restore as file name. SQL Server will default the restore as file names to your data and log directories, depending on the file type. So that's why it restores, in my case, to d:\SQL\data and d:\SQL\logs for me. This also happens to be the place where I hosted those files, as we can see in the original file name. Now, these will often be the same if you are restoring to the same SQL Server instance, or if you have consistent file path layouts across your organization's SQL Server instances. But whether the original file name matches the restore as file name is irrelevant. You can change the restore as file name to anything you'd like, so long as it is a relevant path on your SQL Server instance's underlying file system, that the SQL Server service can access that file path, and that you're not overwriting files that already exist. This is also how we can restore SQL Server on Windows databases to Linux, and vice versa. That original file path does not need to match the restore as file path. If you do want to change the restore as file name, you have a couple of ways to do it. First, you can click on the box for the file you want to change. This allows you to edit the text directly. If you want a file picker menu, select the ellipsis that's next to the text box instead. This will bring up SQL Server's custom file picker menu, and you can use it to navigate to your destination. I will select Cancel to get out of this and show the third option. The third option is to check the box at the top of the page, indicating that we want to relocate all files to a specific folder. If I change the data folder to, say, data2 and the log file folder to logs2, we can see that the file names will change for us. If I have a dozen data files, all of them would change accordingly. But I don't actually have data2 and logs2 folders, so let's uncheck that box and move to the options page. The options page is where we can choose how we wish to restore this database. Our first checkbox for database restoration is the option to overwrite the existing database. Basically, I don't care about what was in that database before or about the backup metadata that existed prior to this. Just bring it back to the state of my backup. That's an option I am going to check here, though I should note that you should be careful checking this box. Database restorations in SQL Server automatically protect you against restoring the wrong database. For example, if I try to restore a full backup for my Analyzing Biz Data database into Chicago parking tickets, there is a metadata difference between what's in the database and what's in the backup file. If you check this box, that will tell SQL Server, forget about whatever exists in the database in SQL Server right now. Instead, I'm starting over with the database contents in my backup file. I find this to be a bit more useful if you're restoring over a database that is in the full recovery model and you don't want the contents of the tail of the log for whatever reason. The next checkbox tells me that I can preserve my replication settings. This is the metadata associated with particular publications or subscriptions, not the publications or subscriptions themselves. Those are stored in a different database. If you are not using replication, you don't need to worry about this flag. If you are using replication, this will be part of the solution for you. I am not using replication, so I will leave it unchecked. The third checkbox asks if you want to restore with restricted user. This allows only people with the sysadmin server role or one of the DB owner or DB creator database roles to access this database. It is particularly useful if you need to restore this database in single user mode and then run the risk of maybe some user or automated process sniping that single user. I'll leave this unchecked, in part because I am the only user of this instance, but also because I am restoring the database in a mode that all users should be able to access it. Next up, we have the recovery state dropdown. We can see that I have three options: restore with recovery, restore with no recovery, and restore with standby. Restoring with recovery means that your recovery is complete, there's nothing more for us to do but open the floodgates and let our users access the database. The main thing that recovery does is that it rolls back any open transactions, saying that, well, those never actually completed and we're going to permanently wipe them. By contrast, no recovery does not roll back any open transactions that the transaction log has recorded. This allows us to continue restoring backups on top of this non-recovered database. Users cannot access the database if it is not operational yet, but it will allow us to continue pushing transaction log backups to this non-recovered database. Incidentally, this is a key part of log shipping, a disaster recovery technique we can use to send occasional transaction log backups over to another SQL Server instance, which then restores those log backups and leaves the database in a non-recovered state. The third option, recover with standby. It's a bit of a weird one. Notice that we do need to specify a standby file. What this option does is that it puts the database in a read-only mode. Like restoring with recovery, it will undo the open transactions in the transaction log. Unlike restoring with recovery, instead of just wiping out those transactions, we actually write them to a standby file. That way, I can switch back to restore with no recovery after I'm done reading the data. This is particularly useful if you need to restore to some specific point in time, such as before a user deleted a particularly important row from a table, but you're not quite sure when that deletion happened. One thing to note is that restore with standby only works on the same version of SQL Server. So if you're backing up from SQL Server 2019 and trying to restore to a SQL Server 2022 instance, you cannot use restore with standby. After that, we have a disabled section on tail log backups. We learned what a tail log backup was in the prior video, but as a recap, this is important if you want to restore on top of a database that is in bulk logged or full recovery model. If your database is currently online, and most databases are, and your database is in one of these recovery models, you have to start with a tail log backup if you are restoring to that database, unless you choose the with replace option. In the server connections section, we have one option, and that is to close existing connections. I highly recommend this, as you cannot restore a database that is currently in use. I'll check that box, and we'll see an information message pop up indicating that this may leave the destination database in single user mode. This happens if there is a failure during database restore, so it is something you might want to keep in mind. Finally, there is a prompt section that gives you a prompt before it restores each subsequent backup. I don't use this much at all, honestly, though I could see the value behind it. Before I kick off the database backup, I am going to open the script menu and script this to a new query window. That way, we'll be able to see what the backup command would run. And it's a good thing I did this. Check out the T-SQL script where it says from disk equals null. The last backup I performed of the Chicago parking tickets database was a performance test. If I try to run this restore operation, I get an error in SSMS that it couldn't read from null. This is quite fortuitous, as it requires that I now show you the other source, devices. Let's switch back to the General tab, and instead of selecting the database source, we'll select Device. From here, I'll choose the ellipsis, which takes me to a Backup Devices menu. Let's select Add, and I will choose the Chicago Parking Tickets.back file, and then select OK. This brings us to a backup that I took on October 1st. Now let's choose Script to New Query Editor window, and we can see the From Disk looks good. With that in play, let's select OK and let this restoration run. It will take a few seconds for restoration to complete, but it will eventually make the Chicago parking tickets database appear for us. You may recall that we encrypted this database backup, but because I have the backup certificate on the SQL Server instance, I don't need to do anything else. As part of the restoration process, SQL Server checks for that certificate, and if it finds the cert, it will use that to perform decryption. If I moved this to a new SQL Server instance, I would need to restore the certificate that I used for backup before I could perform this operation. Backup is now complete. Now I'd like to show you a use of the timeline option. Let's pick the Analyzing Biz Data database. I'll right-click on it and navigate to the Restore menu. Again, by default, we will see the latest backup chain. But this time, I have one full, one differential, and several log backups. I'm going to open this in the New Query Editor window, as we will want to see that restore plan in more detail later. But let's take another look at the timeline. First, let me note a warning at the top of the screen telling me that a tail log backup will be taken. Then I'll scroll to the right on the list of files. We can see that there is a full backup, a differential backup, and 4 log backups. The latest log backup ended at 7:11 p.m. and 42 seconds on October the 1st of 2024. The prior log backup was at 7:09 p.m. and 14 seconds, and before that it was 7:06 and 36 seconds. With that information in mind, let's select the Timeline button. We can see here an option to restore to a specific date and time. I'll choose 7:08 p.m. and 42 seconds. Now I'll select OK. This removes the last transaction log backup from the menu, as we are restoring to a time prior to what that transaction log covers. It covered anything from 7:09 p.m. and 14 seconds up to 7:11 p.m. and 42 seconds, but we're restoring to a time slightly earlier than that. But if we go back to Timeline and move the time forward to 7:12 p.m. and 42 seconds, not only do I see my last transaction log backup, but I also see another entry. This one is for the tail log restore. That's because we want events that occurred after the last successful transaction log backup. I'll select Script for that as well, and then hit Cancel, as I don't actually want to restore an SSMS. The reason is I want to restore it in T-SQL instead. But it turns out that this was actually a pretty clean scenario with SSMS. Oftentimes, however, if you're restoring hundreds or thousands of transaction log backups, the SSMS menu is way too clunky to handle this. Now let's switch to T-SQL and go over each of these backup operations. This will give us a starting point, though I do intend to dig a little bit deeper into those T-SQL restore options as well. Let's take a peek at the first command we tried to run in SSMS. It starts with an alter database operation to set Chicago parking tickets to single user mode. That's because we are not able to restore a database if there are any other active users of that database at the time, including us, which is why we're in the master database to begin with. Then we run the restore operation. Note that the location of the backup file on disk is the null drive, which does not exist. That's why we were not successful in attempting the restore operation. After that, file equals 1 means that we want to pull the first file out of the backup set. If we had a file on disk like chicagoparkingtickets.back, we can jam in multiple backups. The file operator lets us tell SQL Server which of the backups in this physical file location we want to use. I will say that I never purposefully back up multiple times to the same file. The biggest concern I can think of off the top of my head with backing up multiple times to the same file is if something goes wrong with that backup file, all of your eggs are in one basket, so to speak. The next command is no unload, which is a tape drive option that SSMS puts in automatically. I'll ignore that because I don't have a tape drive. The replace command was our with replace checkbox. Stats equals 5 tells us that we're going to see an update message on screen for every 5% of the restore process that SQL Server completes. Finally, after we restore, we set the database back to multi-user mode and enable people to make use of it again. Obviously, I'm not going to run this script because it will fail. Instead, let's close that window and move to the next script. This one looks very similar, except that I have an actual location on disk. We can see a proper backup file location on disk, and otherwise everything is the same. It won't hurt to run this again, so let's kick it off and watch our database restoration happen. This will take a few moments, during which time I'll need to vamp. So let me vamp about a couple of other database restore options that we're probably not going to cover in this series. Looking through the syntax section, we have a pseudo language that describes the commands we can use, many of which we saw in SSMS. In case you don't have much experience reading this kind of a syntax diagram, let me briefly take you through some of it. We restore a database, either directly from a name or from some database name variable that you can pass in. Next, we can have one or more backup devices. Note that backup device has angle brackets and there's array-like notation after it. This is telling us that there is a backup device section in the syntax and that we can have one or more of these entries, which would happen if we took a database backup over multiple files. That is a common technique that will help with backup performance, and we'll talk about that actually in the next video. Let's scroll down to the backup device section. In here, backup device is going to be one of two things. It will be either a logical backup device name or a physical backup device. You can add logical backup devices through the sp_add dump device. That is a D dump device, I suppose, so that there aren't 3 Ds in a row. Now, I almost never see this in action, but it is a way of simplifying your backup and restore statements a little bit. For the most part, I simply define the physical backup name, which can be one of disk, tape, or URL. Tape only makes sense if you have a tape drive, of course, and URL is if you want to store backups someplace like Azure Blob Storage or S3. Scrolling back up to the restore database operation, you can see that there are several sections with options, including replication, change data capture, file stream, and service broker. If you are using any of those technologies within a given database, you might be interested in digging through those settings. Otherwise, they're not going to matter for you. There are other options to restore specific files or file groups, and that's a topic we will cover in a future video. In addition, there are ways to restore a specific page or to restore a transaction log file. Speaking of restoring transaction log files, let's switch back to SSMS and do that. This is the command we created to restore the Analyzing Biz Data database to its most recent log backup point, which was October 1st of 2024 at 7:11 p.m. and 42 seconds. The first thing we need to do is take a tail log backup, so that's why we have a backup log file here. We have talked about what these backup settings do in a prior video, so I'll skip down to the restore database commands. We have one for full backup, then the next is for our second differential backup. In a prior video, I set up a chain of backups from one differential and then started a new chain from our second differential. In that video, I mentioned that taking a differential backup resets the log chain, such that you don't need any log backups from between the full and the differential you want to use. And this actually proves it. I pull in analyzing biz data 2.diff, but not the first differential backup or any transaction log backups associated with it. After that, we have 4 restore log commands. This allows us, naturally, to restore from a transaction log backup. Note that the syntax is pretty similar. Also note that I just happen to have a case where I wrote 2 separate transaction log backups to the same file on my share drive. Thus, we see file equals 1 and file equals 2, telling SQL Server to use both of those files in the restore effort. In lieu of running that, however, let's look at the final script that I've saved. This one looks very similar. We take a tail log backup and then restore the full backup and differential, followed by each of the transaction log files on disk. But now we include the tail log backup and a stop at command. This stop at command tells SQL Server the exact date and time we want to use for our restore operation. Now let's spend a few minutes looking at the DBATools option for restoring databases. On the DBATools website, we can see the commands related to database backup and restoration. On here, I'm going to select the Restore DBA Database commandlet. We can then scroll through the syntax of this command, which includes a lot of flags. Some of this stuff matches what we've already seen in T-SQL, such as database name, where we put the destination data in log files, whether we want to leave this in recovery or no recovery mode, whether we want to replace the database, keep replication, and so on. There are also some additional settings that we'll get to when we talk about database performance tuning, and even several flags for stop points, including stop before, stop mark, and stop after date. Interestingly enough, none of these tie back to the stop at command in T-SQL. That is a parameter called restore time. So let's talk a little bit about these stop parameters. The stop mark parameter allows you to stop at a specific named transaction. When you begin a transaction, you can specify a mark with a description, which might be something like data warehouse load has begun. This description has a limit of 128 characters, so it is best to be somewhat parsimonious in your description. Then, when you want to restore the database, you could use the stop before command to decide whether to stop right before that marked transaction or stop after it completes. What's particularly interesting about marking transactions is that this is your key way of ensuring cross-database transactional consistency on restores. So that way you can restore each database connected to the marked transaction to the point when that transaction began or completed. This is not a feature I see many people take advantage of, but it does exist in SQL Server and it could be useful for certain advanced backup and recovery scenarios. Anyhow, let's scroll back up and see some examples before we dig in. The goal of this commandlet is to simplify the process of restoring backups, and it takes advantage of whatever backup metadata and backup files you have. There are 17 separate examples covering a variety of backup scenarios, from restoring a single database from a single backup file to restoring a whole slew of databases based on a set of database backups in some collection of folders. Let's simulate a couple of our restore operations and see how we could redo them using DBATools. First up is a simple database restore of the Chicago parking tickets database. First, we'll need to import the DBATools module. Once I've imported the module, I can get to work. We are going to restore the chicago.back file, overwriting the Chicago parking tickets database. Note that I also have a flag on here, what if. This flag says that I want DBATools to tell me what would happen, but not actually to do it. That way I can make sure my script does what I expect it to do. And when I run this one, I get several warnings telling me that restoration will not work because there is already a Chicago parking tickets database and its lineage is a bit different from what's in the original backup. One option that I have here is to restore with a different database name. So I could add a database name in here, Chicago Parking Tickets 2, and that would restore successfully. Now, another option that I have is to restore the database with replacement. In this case, DBATools says, hey, this would work just fine. But what happens if I drop the database name? In this case, DBATools reads the metadata for the backup file and says, oh, hey, the database we want to restore is called Chicago Parking Tickets. It then gives me the same warning message around how I already have this database and would need to choose the with replace if I wanted to perform this restoration. Now let's try analyzing biz data. This script will restore the analyzing biz data database to 7:11 p.m. and 42 seconds on October the 1st. Of note is that the stop at parameters equivalent is restore time, as I mentioned. There is a stop after date parameter that at first glance might look to be the correct one, but it's not going to work the way you expect. I also have the path parameter set as an array containing 2 locations, the SQL backups on my J drive, as well as SQL backups on my R9 share. This shows that we can have backups in multiple folders and it'll work just fine. When we run this, we can see that it pulls in all of my transaction logs. Let's push the time back a few minutes to 5 minutes after the hour. In this case, we pull in the full backup, differential backup, and the first transaction log. And if I push it back a couple of minutes earlier, well, in this case, we can see the first differential backup and first transaction log backup. This tells us that the DBATools commandlet is smart enough to parse out what it needs to do without me directly specifying those backup files. All in all, there's a lot of neat stuff that you can do with database restoration in Management Studio via T-SQL and using the DBATools module in PowerShell. And that was our dive into database restoration. I hope that I gave you a pretty decent idea of some of the things that you can do with a variety of SQL Server related tools. There is naturally more available than I could cover in this single video, but hopefully I've given you an idea of some of what you can do. I'll also include a few interesting links in the show notes. In the next video, we will get an idea of what kinds of options are available for tuning backups, as well as how you can figure out which options you should select and what values you should select for those options. We'll have links and show notes in the description below, and until we see each other in the next video, take care.